when we say change of base law, right? People who were in my semester course, my elective course last year, will know I kind of have this love-hate relationship with the word law when it refers to maths. Because kind of like when I think of law, it's kind of like what we've decided about how things should run, about what's the, you should drive on this side of the road and you should pay these kinds of taxes and so on, right? And they're made up by people. But in maths, as in science, laws are nothing like that. It's just kind of the nature of things as we discover them and how we try to articulate that, right? So, before we dive into this, just to get our heads in the right space, stick your hands up. We have a lot of laws that we already know from the index law. So, someone want to give me a suggestion? What's a law? We should have at least 4 or 5 off the top of our heads. Someone give me an easy one? Yeah?
Is it log base A mn is equal to log base A n plus log base A n?
Fantastic. Okay, good. By the way, that's exactly the way pretty much the way I say it. I tend to read these as log base A of m. Of m. If you remember what we were saying about my metaphor for understanding what logs are about, right? You say the size of something is its rate to the power of its time, right? So this is how big it's going to be at a given growth rate. So when you convert this into a log equation, it's going to be log base, the bases stay the same, r of s equals t, right? So the idea is that you've got this whole thing on the left-hand side is actually a period of time, right? And you're growing at a certain rate and you're getting to a certain size. So of that size is what I'm saying. All right, good. That's one. It has its reverse. What's its reverse? Log base A of m on n. Good. Good money. Is instead of addition of times, right? When you're dividing, you're taking the difference between the times, right? Okay, excellent. Someone else give me another one. Someone hasn't said anything yet. Yeah, Raf.
Log base A log 1 equals 0.
Okay, excellent. What's the amount of time it takes to be the size you already are? Answer, you're already that size, so no amount of time at all. Okay, 0. Someone give me another one.
Log AA equals 1.
Log base A of A is 1. How long does it take to get to be 8 times bigger than what I am if I'm growing at a rate of A? And the answer is 1 time period. Okay. Another one. We're starting to get to the tricky ones now. What with powers? Powers. Log. I'll start like this. What shall I add to this? To the power of. You can call it anything you like, I suppose. If I call it n, where's that power going to go? It's going to come out the front, right? Now, we didn't explore this one before, though really, it's just a special case of this one, is it not? It's just a special case of the first one. Can you see that, right? Can you see why that works? Think back in terms of time, right? If you wanted to grow at such and such a rate and be that times bigger, you're going to have to do it that many times to grow to that point, right? Okay, that looks pretty good, doesn't it? Yep.
Isn't the change of base from log base?
Okay, all right. Let's do the change of base law because we're pretty much there. Okay. Log. Good morning. Base A of B. Okay. So here's the idea that if you have some time period expressed in some growth rate, right? We can change it to be in terms of from some other growth rate using the change of base law. In fact, the base is really the growth rate, right? We have a fraction here, log base A is base of something, and another base, right? Okay, who remembers it? Anyone? Somebody hasn't said anything yet. Yeah, Josh, you have a go?
Log B over log A.
Okay, alright, so you've got the B at the top and the A at the bottom. So that's how you remember the position of the B and the A, right? Now, what do you fill in here for the bases? And the answer is anything you like, okay? So for instance, the standard way that this is written is with a C. It just means, some other number, okay? It's worth mentioning at this point, this is a good enough time to say it as any, that there are some conventions for how to write different logs. Like if I had written it without a letter there, if I just written this, okay, this has a meaning as well, but it's a bit tricky, which is why I'm making a special note of it. If you see this anywhere except for your calculator, then when you don't see a base, there's a base implied, namely. Now if it's anywhere except your calculator, the base that's implied is E, right? Now we'll get into E very soon. It's a very important number, as you might be able to imagine. It's implied, and another way of writing base E, an even shorter way, my way, is my favorite way, is with Ln. The N stands for natural. And why is E the natural number to be the base of a log? Well, we'll explore that, okay? Now, I said anywhere except for your calculator. If it is on your calculator, and there's an easy way to remember this, by the way, but I'll show you in a second. If it is on your calculator and there's no number, what base is implied? It's a base 10. Now, that's for two reasons. Number one, if you reach for your calculator now, you should do this. Get your calculator out. And the easy way to remember that on your calculator it means base 10 and nowhere else is because when you look at your log button on your calculator, right? And you can press, log of 5 or something like that, and sure enough, it comes up, it looks like this with no base. When you look above the button that says log, it says 10 to the power of. So 10 is the base, right? 10 is the rate at which it's growing, okay, or whatever it is. So that's the first reason that you can either remember on a calculator, it's base 10. I might even write that. This is calculator only. If you see it written in a textbook or in an exam or anywhere else, it means base E. Come in, text it. The other reason to remember that it's base 10 is because, what kind of calculator is this? Like, it has a name, right? Oh, okay, the brand is Casio. But broadly speaking, the category of calculators is it's a scientific calculator. Now, what base are scientists interested in? Because they use scientific notation. Answer, base 10. That's what scientific notation uses, okay? So that's how I remember that on a calculator, that's what I'm using. Hopefully that's enough cues for you not to confuse it anymore.